For 7.4, we're just going to do this in 3 parts, A, B, and C. So today is just going to be part A, and we're still working on solving systems. So I have some of the examples that are in your notes packet for 7.4A. And we're still solving systems with elimination like we were doing yesterday. And so elimination means that we're going to try to cross off one of the variables. We're going to try to eliminate either the x's or the y's. So in yesterday's lesson, we would find that we had a pair of x's or y's that was matching, and this time we don't. So we have to make that happen. So I'm looking at this and see here's 6 x's and here's 2 x's. And if I wanted those to match, I could make that happen if I multiplied everything in the bottom row by 3. And you can do that as long as you multiply every single part of the equation by the same number. You're allowed to do that. So I'm going to go across this equation and times everything by 3. So I'm going to do 3 times 2x is 6x, 3 times 3y is 9y, and then on the other side of the equal sign, 3 times 5 is 15. So I have just rewritten that bottom equation, and I'm going to use this new one now instead. So now I'm going to bring this top equation underneath it. It doesn't matter which one's on the top or the bottom, but I just want to get them near each other. So I'm just rewriting that exactly the way it is. And then it becomes a problem just like yesterday's problems. So I have to decide if I either want to add or subtract. And for these equations, since the 6x and the 6x are exactly the same, I'm going to need to subtract. So I'll do 6x minus 6x is 0, and they are eliminated. And then I'll be doing 9y minus 5y, because remember I'm subtracting, so that would be 4y. And then I'll do 15 minus 19, and that would be negative 4. And then if I just keep solving that, I'll end up with y equals negative 1. So that's part of the answer. Then to find the second value to figure out what x is, I can go to any one of these equations. The original ones, I can go to the new ones. Any equation will work. So I'm going to take that negative 1 and I'm going to put it right here in place of y. It says it equals y, so I'll put it in place of y. And now to rewrite this equation on the top, putting the y, the negative 1. Okay, so I'm going to multiply 5 times negative 1 right here. So now that equation says 6x, and then 5 times negative 1 is negative 5 equals 19. And then I'm going to solve this equation, so I'll add 5 to both sides, and I'll get 6x equals 24. And then I'll divide both sides by 6, and I'll get x equals 4. So then my answer is x equals 4 and y equals negative 1. Okay, let's try the next example. So when I look at this problem, just like happened yesterday sometimes, like this top equation is written in what's called standard form. It's all lined up with the x's first and then the y's and the constants on the other side. But the bottom equation isn't really in standard form, so I need to take these 3 x's and move them out to the front. And the way we do that is by subtracting 3 x's from both sides of the equation. So then what would happen is I would have the negative 3x. This 2y was positive, so I'll have plus 2y. The 3x minus 3x cancels out, and it's going to say equals negative 9. And then I'll write this equation right underneath it. So now I have 4x plus 5y equals 35. Okay, so at least they're lined up in standard form right now, but there still isn't a match. In other words, like the negative 3x and the 4x are not the same number, and the 2y and the 5y don't have the same number. That's called a coefficient, that number, and they don't match. So what I need to do is get one of those pairs to match. I could either decide to turn the 2 and the 5 maybe both into 10s. That would be pretty easy. Or I could turn the 3 and the 4 both into 12s. I'm going to do the 3 and the 4. So I'm going to multiply everything on the top row by 4. So I'm just going across the line and I'm doing 4 times negative 3x is negative 12x. 4 times 2y is 8y. And 4 times negative 9 is negative 36. And then I'm going to go across the bottom row and multiply everything by 3. And so I'm just going 3 times 4x is 12x. 3 times 5y is 15y, and 3 times 35 is 105. Okay, now this time it turned out that the variable that kind of matches up here, they're opposites. The negative 12x and the positive 12x are opposites. So that's good. That works really well because now I can just add my lines together and those x's will be eliminated. And then if I add up the y's, 8y's plus 15y's is 23y's. And if I add these constant numbers, that's going to equal 69. And then I'll keep solving that, so I'll divide both sides by 23 and figure out that y equals 3. Then I need to go to any equation. It doesn't make any difference which one, so I'm just going to use this top one, and I'm going to put a 3 in place of y. Just make sure to put it in the right variable. And now I'll rewrite this top equation. So now it says 4x plus 15, because I'm doing 5 times 3 right there, equals 35. And then I'll finish solving that one. So we get x equals 5. Okay, so we're going to just do one more. And this, we're going to skip number 3 for now. That's not really anything that we have to worry about until tomorrow. So here's one more example. So see if you know what you would do first on this one. We're looking at number 4. I think we have the same equations. If we don't, you could change yours to say what mine say. And see if you know what you have to do first. So hopefully what you're doing is subtracting 5x's from both sides to get the bottom equation in standard form. And then we would look at these equations and decide if we were trying to get the x's or the y's to match. I'm going to work on the x's. So I'll multiply the top row by a 5 and the bottom row by a 3. And that way the coefficients on the x's will both be 15s. One will be a positive 15 and one will be a negative 15, and that's fine. That's actually good. So I'm going across the top row, multiplying everything by 5. And then I'll go across the bottom row and multiply everything by 3. Then I'll look at my system, and because the 15x and the minus 50 or the negative 15x are opposites, then I'm going to need to add these two lines together. The x's are eliminated. We'll get negative 8y equals 40 if we add those lines together. And then when we divide by negative 8, it turns out that y is negative 5. We'll take that back to the original equation, any one of the equations, and put the negative 5 in place of y. I'm using the top equation, and it would now become 3x plus 35 equals 5, because I'm multiplying the negative 7 and the negative 5. Then I'd solve this equation. I'd have 3x equals negative 30, and x equals negative 10. And then I think you have 6 or 7 of these problems to do and a couple review problems. So it's going to be 7.4a. It should be open. And please remember to send me a picture of your notes. And we have to just make sure that in order for you guys to keep working in the IMC, we have to keep you caught up. So let me know, come and see me in homeroom, or let me know if you're having trouble staying caught up. I mean, I'm checking on it a little bit too, but let me know if you want some help.